So word problems. If it's exponential, right? If you have an, I'm just going to give you a bunch of examples. If you have something like this, and I ask a bunch of questions about it, but then ultimately I ask you to sketch this, or to graph it, I should say. Right? This is not a pretty graph, okay? I'm just letting you know. You have to have labels. But your y-intercept is 0, 2000, and b is greater than 1, so it's increasing. So this is even just to match an equation to a graph, right? This would be very helpful. So you must start somewhere along the, you can never be on the origin because these do not have x-intercepts, right? So you're somewhere in here in the 2000s, and then it goes up. Meaning, your scale, guys, when you come up with your scale, please do not like just go up to 2000 and you make a dot here and then you go out into the open space. Like you should have, oh, if this is 2000, then I should probably go up to 10,000, right? Just so we see that shape of an exponential function. Most of the time, there will be some sort of hint in the question that tells you how far out you should go, okay? So if it wants it over 100 years or over 200 years, whatever, then you find that point and find the y value, which gets you back to figuring out what scale should you be using, okay? If it's another example here, y is equal to 100, and you have 0.90 to the x, right? Your y-intercept is 0, 100. B is between 0 and 1. You can't have a negative value. That's why I'm going between 0 and 1. Technically, I think if I just said less than 1, you would all understand it's a decimal between 0 and 1. So this is decreasing. Okay. So if you want to graph this scenario, you're going to start somewhere up here. So this one, in a sense, in terms of your y scale, this one is easier because you know that's the highest you get. And then from there, you're going to start approaching your x-axis. Okay? So this is 0, 100. Boom, you got that. Okay? So the key is, y-intercept is always given, right? You don't have to guess on that one. Y-intercept, I mean, if the equation is provided, sometimes you have to come up with the equation, and then you find out your y-intercept. But that's that, okay? Let's talk about the domain and range. So excited about the domain and range, eh? Next door. Yeah, I don't blame them. For the domain, you will start at 0, right? Your x value here on the y-axis is 0, and then it keeps going indefinitely. So in this case, it would be infinity, right? We're not told that it stops. So you have to watch out. If it stops, you would obviously figure out that stopping point, and that would be the limit for your x max, right? Like your highest x value. For range, in this case, you go as low as 2,000 for your y value, and then it keeps going up, right? This graph just keeps going up indefinitely. So you'd go from 2,000, that's the lowest y value, to infinity. I'm a little hesitant with giving you the domain and range because you're going to be like, oh, there's always going to be an infinity. That depends on the question, okay? In my case here, it doesn't end. It just keeps going, okay? This one here, for the domain, it's still the same. It's 0, right? 0 to infinity. Infinity always gets a round bracket, okay? For your range, Oops, this one is trickier. What's the lowest y value you get to technically? Almost 0. Because remember, there's an asymptote here, it never touches. So it's almost 0, that's the lowest. And then the highest y value is 100, so it looks like that. Remember, at the top of this page, I put word problems, right? This is word problems, like you're restricted to the first quadrant. If it's just a general equation, you have to go back. I asked you to copy for logarithmics and for exponentials. There's like this box with just general information on the domain and range. Like the domain would be negative infinity, positive infinity, right? For a general exponential. And the range would be 0 to infinity, right? So you got to watch out. So that's exponential. When you do logarithmics, it looks like this. So I'm going to give you 2 examples. So you either have, I shouldn't use y all the time because it'll be a, m, t, it could be anything. This could be negative 200 plus 150 natural log of x. And this could be log or it could be natural log. So if the equation is given to you, you have to type in the correct one. If you do a regression, it's always natural log. There's no option of doing the regular log, right? So in this case, because it's a word problem, this is a right here, this is b. B is positive. So sometimes these are flipped, guys. Like you have the 150 natural log minus 200, and some students think, oh, it's minus 200, so it's decreasing. Just look at the value in front of natural log b. So b is positive, right? Positive, so it's increasing. That's what matters. And so if you were to graph this, I like to sketch it no matter what, even if I'm just answering questions. I like to like sketch it and put some points down just to help me out. But remember that 1a is a point on this graph, guys, in general. 1a is like 1 negative 200 would be on there, but we don't care if it's a word problem. It doesn't help us. We need to start somewhere on the x-axis. Okay, so this graph is probably going, you got to find the x-intercept, and then from there you're going to go like this. Okay, so I will put down must find x-intercept. That is your key to success with logs. And so if this is 100, let's say, then maybe your x-axis should go all the way to like 1,000 or 2,000 so that you can see that shape. So that's what I would say if it doesn't tell you where to stop. Another example, that this will be a decreasing example. Let's say a is equal to 175 minus 23.5 log of x. Again, sure, A is good. It helps us sometimes, but B is the one you want to look at for sure. So B is less than 0, which is negative. Okay. So this is decreasing. Whatever you're looking at is decreasing over time, or the amount of money is decreasing over time. So for this one, and I keep forgetting our asymptote, right? A logarithmic has the asymptote x is equal to 0, right? It just never crosses it. So for a decreasing function, it's a little trickier. It's going to come down like this. So you still must find the x-intercept. Okay, so I'm going to put that down here. Must find x-intercept. So even if the question doesn't ask for it, you have to find it to give you a bit of a reference. Where am I going? And so this one will be coming in like this. It's decreasing over time, and it hits the x-axis there. Put an arrowhead here. This keeps on getting infinitely closer, but never touching your y-axis. So there you have the two cases of your logs. Could we use 1a in this case? 1a is actually very helpful. 175 would give you a bit of a reference point here, and then you find something in between to give you that curve, right? Use your calculator to find another point somewhere here to help you out with that. Let's do the best part, which is domain and range, right? You were all looking forward to that. For domain and range in this one, it would be, let me just do this. I'm going to tell you that it's the x-intercept to infinity, like that x-intercept right there. And range would be from 0 to infinity in this case. I know I'm just doing interval notation here. I hope you are okay with that. My domain here, what's the lowest x value here? Almost 0. I say almost 0. It never touches. So you got to do round bracket. So 0 all the way to x-intercept. That's where the x value stops, right? So I'm just going to go x-intercept like this. And for range, it goes from 0, like your lowest y value is 0, all the way to infinity, right? So it's 0 to infinity is your range in this case. That's all I'm going to say. I just wanted to have one more